Hey my friends, today we are going to be talking about how to graph logarithms. The beginning of this week we graphed some more simple logarithms, and then by the end of the week we had progressed to some that were a little bit more complicated. In this video we will talk about graphing logarithms, each with an individual transformation and then combining the two transformations at the end. So when we started at the beginning of the week, we were graphing pretty basic logarithms in which, say we were trying to graph a logarithm which had a base of 3. We talked about how b told us what we were multiplying by when we created our number line. So we would start by 1 and keep multiplying by 3, and then we could divide by 3 going the other way. And we could then use this number line to transition into creating a table of values, which would then help us graph. We then remembered to talk about how x, the argument of the function, represents where we are landing on our number line, and that the y value, the output, is going to represent the number of jumps. So when I take my number line to transition to a table of values, we could say that if I was going to land on 1/27th, that would take me -3 jumps, because I would go 3 jumps to the left. 1/9 would be -2 jumps. 1/3 would be -1 jumps. 1 would take me 0 jumps. 3, 1 jump to the right. 9, 2 jumps to the right. 27, 3 jumps to the right, and so on. And we then talked about how we could graph these, and I don't have any graph paper on this page, but how this would end up looking something like so. And this is kind of our shape of a logarithmic function. Okay, so we are going to talk in some more detail today about, okay, how do we graph these if it's a little more complicated than that? So we talked about 2 types of transformations. We talked about adding k to the end of a logarithm and how this would impact the y values in our table, causing a vertical shift on the graph. And then we added in, okay, what if we change h, which is inside this argument? It's impacting the where we land part on our number line as opposed to the number of jumps. And it's impacting the x values in our table, and therefore creating a horizontal shift on the graph. So we're going to take a look at these 2 separately. Okay, what happens if I just change k? What happens if I just change h? And then we're going to combine them both together at the last part of this video. So in this first example, we are adding 5 to the end of the problem, so we are adjusting k. As opposed to, I'm going to just switch to the next slide for a second. Here, where the add 5 is in parentheses in with the x, that means I'm changing the h value. So here I'm adjusting the k value. So my y values are going to get impacted in my table. But the way I start is going to be the same, right? I have a base 3, so I'm going to start with making my number line a base 3. And these values, the where I land, are going to help me determine my x values. So if I want to land on 1/27th, so log base 3 of 1/27th, that would be -3 jumps. But this +5 means I'm adding 5 to that y value, which is going to ultimately get me a y value of +2. Okay. Next, if I looked at 1/9th, log base 3 of 1/9 is -2 because it takes me 2 jumps to get there to the left. But then I'm going to add 5, and that's going to get me 3. If I go to 1/3, log base 3 of 1/3 is -1, 1 jump to the left, +5 is going to get me to 4. And then say I use 1. Log base 3 of 1 is 0. It's going to take me 0 jumps because that's where I start. +5 is going to get me to 5. And then if I did 3, log base 3 of 3 is 1 because it's going to take me 1 jump to the right. plus 5 is 6. And I could keep going, right? 9 would fit on my graph as well, so why don't we add that in here? Log base 3 of 9 is 2. 2 jumps plus 5 is going to get me to 7. So this k value simply just helped kind of bump all of my y values up 5. So instead of taking negative 3 jumps, negative 3 plus 5 got me a y value of 2. Negative 2 plus 5 got me a y value of 3. So it shifted all of the original y values, which represented the number of jumps on my number line, up 5. And now I'm going to graph this. So I'm going to start with my whole numbers just because they're a little easier to plot. 1, 5, 3, 6, 9, 7. I'm going to go a little off the top here just so I didn't make my graph paper big enough. And then 1/3 would be a little bit to the right, 1/3, 4. And then 1/9 is going to be even a little bit less to the right of 0, 1/9, 3. 1/27 is like pretty much 0, 1/27, 2. And we can see that I only plotted 6 points, sorry. But based on what we talked about in class, right, I could keep going. I could put 27 in, and then I would get out 8. I could put 81. So we're going to have this slow and kind of steady increase as I continue to the right. So this arrow is going to indicate to me that I'm going up as I continue on to the right. Similarly, if I was to extend my number line the other way, I would have 1/81, and that would take me negative 4 plus 5, which would get me 1. And we can see that these x values are just going to keep getting smaller and smaller, but they're going to stay positive fractions. They're never going to get below 0. I'm going to have 1/81, and then 1/243, and then 1 over a bigger number, and they're going to get smaller and smaller and closer to 0. And these y values, the number of jumps, are going to get smaller and smaller and smaller. So my graph is going to continue straight down, skimming the y-axis. And that indicates that we're going to have a vertical asymptote at x equals 0. Because this x equals 0 value, we are never going to hit. Because when we create this number line, remember, let's go back to how we started learning about logs, there's no way that we're going to get 0 on our number line. We're going to keep getting smaller and smaller fractions, but we're never going to hit 0. So my vertical asymptote is x equals 0. My domain, which is how does the graph move from left to right, well, it's not going to go all the way to the left. It's going to stop at 0, but it will continue all the way to the right. My range, negative infinity to infinity, right? Remember, range is bottom to top. So the bottom of the graph is going to keep going down to negative infinity, right? I could have a negative infinity jumps. That would just mean a lot of jumps to the left. And then it's going to continue slowly moving up as well. Increasing and decreasing, remember we read from left to right. So if I start at the left side of my graph and I trace it, I am increasing the whole time. So for my decreasing interval, I can write none. And I'm increasing on my entire domain. So I'm going to increase from 0 to infinity. So there was an example of a logarithm function that had a k value, this plus 5 being added on. And all that did was shift our values up 5. What is a little more challenging is when we shift inside the argument. So we shift this h value inside of the logarithm. So we're going to start out the same way. I'm going to create my number line using base 3. So all else fails, kind of here's where you're going to always start. 1, 3, 9, 27. I'm going to go my other way. 1/3, 1/9, 1/27. And normally, these are the values we would put in for x in our table. But I'm just going to give you an example for a second. Say we put 9 as one of the x values in our table. Well, when we go to evaluate it, we're not really doing log base 3 and 9, which normally would get us 2 for 2 jumps. We're doing log base 3 of 9 plus 5. And 9 plus 5 is 14. So we're really doing log base 3 of 14. And we don't want to do that because 14 is going to be a decimal. So what we're going to do instead is we're going to try to create these numbers we want. So if I want the numbers that I want to hit are 1, 3, 9, 27. Those are the numbers I want to land on. Those are what I want my x values to be. What I need to think about is what number plus 5 will get me there. So a few ways you can think about that is we're trying to think about what number plus 5 will get me to 1, what number plus 5 will get me to 3, what number plus 5 will get me to 9, what number plus 5 will get me to 27. Or some of you prefer to solve an equation, so we could say x plus 5 is equal to 1, and we could subtract 5 from both sides and solve. Whatever works for you, but basically we're going to just use 9 again. If I want to get to 9, because I'm adding 5 first, I don't want to actually put 9 in for x. I want to put 4 in for x, because 4 plus 5 is going to get me to 9. Okay. Same thing, if I want to get to 27, I can't put 27 in for x because 27 plus 5, right? Parentheses means I do that first, so I have to add that 5 right away. As opposed to in the previous example where I was able to calculate the logarithm and then add 5. Here, because I'm adding 5 right away, I would want to put in 22 because 22 plus 5 is going to get me to 27. So really, all I'm doing is subtracting 5 from each of these values to help me figure out what I can add 5 to get those values. So 27 minus 5 is 22, so 22 plus 5 is 27. 9 minus 5 is 4, so 4 plus 5 is 9. 3 minus 5 is negative 2, so negative 2 plus 5 will get me to 3. And then 1 minus 5 is negative 4, so negative 4 plus 5 is going to get me to 1. And those are all good numbers on my number line. The fractions are a little bit harder here, so if you want to just do 1 rather than doing a couple in your table, that's fine. But similarly, I could take 1/3 and subtract 5, and that's going to get me negative 4 2/3. Okay, so now the y values are pretty easy. They're just our jumps. So 22 is really getting, plus 5 is getting us to 27. Well, it's going to take me 1, 2, 3 jumps to get to 27. 4 plus 5 is going to get me 9. It's going to take me 2 jumps to get to 9. Negative 2 plus 5 is going to get me to 3. It's going to take me 1 jump to get to 3. Negative 4 plus 5 is 1. Takes me 0 jumps to get to 1. And then negative 4 2/3 plus 5 is going to get me 1/3, and it's going to take me 1 jump to the left to get there. Okay, so I'm going to just put these numbers on the side, which are the numbers I was landing on coming from my number line. And then the x values I'm actually used is just taking them all and adjusting them by 5. Specifically, I subtracted 5 from each of them because in the problem, I'm adding 5 to them. So now when I go to graph, let's see, 22, 3 is not going to fit on my graph, but I can do 1, 2, 3, 4, 2. That fits on my graph. Negative 2, negative 1. That fits on my graph. Sorry, I'm going to have to go off a little bit here. Negative 4, 0. Sorry, this one was positive 1. And negative 4 2/3, so sorry, you're part of my graph here a little bit, would be a little bit more to the left and then down 1, negative 1. So it's going to look something like so. And then remember on this side, we're going to continue going down. Okay. So my vertical asymptote, and pardon me for this being off the graph, my vertical asymptote is going to be right here, and it's going to be at -5. Because if we were going to keep going, I would keep getting -4 point something, -4 point something, but I would never hit -5. So my vertical asymptote is here at -5. My domain now is from -5 to infinity. So because -5 is the farthest left number. My range is still -infinity to infinity. I am increasing the entire time, so I'm going to increase on my entire domain, and I am not decreasing at all. Okay, so now we are going to do one final example where we combine both transformations. And let me just make sure I have one that will fit on our graph here. I do. Okay. So we are going to graph y equals log base 2 of x plus 1 minus 4. So I'm going to make my number line using base 2. So 1 times 2 is 2 times 2 is 4. Some of you like to put 6 next for this one. Remember, times 2 is 8. Okay, then I could keep going to 16, and then I would have 1/2, 1/4, 1/8, 1/16. Cool. So I have my numbers on my number line. So I think it helps to write them next to it. So I'm definitely going to use 8, 4, 2, and 1 are great spots to land, right? 1, 2, 4, and 8. And then I'll just do one fraction, 1/2, because 16 is not going to fit on my graph paper. So there are my 5 points I'm trying to land on. So the first thing I have to do before I even kind of start finding where to land on my number line is I'm going to add 1 to whatever number I choose. So if I want to land on 8, that means I need to actually put 7 in for x, because 7 plus 1 is going to get me to 8. So another way to think about it is we're taking each of these values and we're subtracting 1 from each of them, and that's going to help me figure out what number to put in for x, so that when I add 1, I get to the number I actually want. So 8 minus 1 gave me 7. 4 minus 1 is going to give me 3. 2 minus 1 is going to give me 1. 0 minus 1 is going to give me 0. And 1/2 minus 1 is going to give me -1/2. So I subtracted 1 from each of those values to get my x values. And now we're going to figure out our jumps. So if I am starting with x is equal to 7, 7 plus 1 is getting me to 8. So that is taking me 1, 2, 3 jumps to get to 8. But then we have this minus 4. So I need to remember to subtract 4, which is going to get me to -1. Okay. Then next, So when I put in 3 for x, 3 plus 1 is going to get me 4. It's going to take me 2 jumps to get to 4. But then this minus 4 tells me I need to subtract 4, which is going to get me to -2. Then next, I'm putting in 1 for x. 1 plus 1 is going to get me to 2. So that's going to take me 1 jump to get to 2. And then I'm subtracting 4, which is going to get me to -3. When I put 0 in for x, 0 plus 1 is going to get me to 1. I don't have to take any jumps. And then I'm subtracting 4, which is going to get me to -4. And then last but not least, this -1/2 plus 1 gets me to +1/2. That's going to take me 1 jump to the left, but then I'm going to subtract 4 to get me to -5. So now I'm going to go graph my points, and just remember, these are the values I'm plotting. All that other stuff is just my work to help me evaluate. So 7, -1, 3, -2, 1, -3, 0, -4, -1/2, so I'm just going halfway to the left, -5. And so my graph is going to look like so. And this time, my vertical asymptote is going to be at -1. I'm never going to hit -1. Remember, in our more simple logarithms, when we just graphed this, our vertical asymptote was at 0. But now I'm shifting my vertical asymptote to the left 1. So my new vertical asymptote is at -1 for this problem. And that's because I had to subtract 1 from all the x values I wanted to use. I know it's a little confusing. We subtracted 1 from all the x values we wanted to use so that when we added 1, like it tells us in the problem, we got to values we liked. So, right, we wanted to get to 8, but the problem said to add 1. So that means we actually had to start at 7, 1 less than 8, because 7 plus 1 gets me to 8. So my vertical asymptote is at x equals -1. That means my domain is from -1 to infinity. My range, -infinity to infinity, because I can always have, remember, y comes from jumps. You can have a ton of big positive jumps or a ton of negative jumps. That's totally fine. It is increasing on my entire domain, and I am never decreasing. So there you go. We did 3 examples. We did one that just had a change to the y values. Hopefully that one's not too bad. Then we got a little bit harder where we talked about how we have to shift the numbers on our number line. And remember here, right here was +5. So that means we actually, to account for that, we had to subtract 5 from all our x values, which is why our vertical asymptote ended up being shifted to the left at -5. And then in our last example, we combined them both together. So this +1 shifted the values we landed on in our number line, and then this -4 impacted the y values, or the number of jumps. Okay, hope that was helpful, and let us know if you need anything else. See ya!